Picking up with our Algebra 2 final exam review, let's look at number 13. We saw this problem a lot in Chapter 7. Really, we're combining like terms. These radicals are identical. 3 minus 5 is actually negative 2. And we'd have negative 2 times this square root of a to the 5th b squared. But just remember that this is a square root. So we're looking for two of the same item. We've got 5 a's, and then we have 2 b's. And we're always going to look for two of the same type of items. So we've got 2 right here, we've got 2 a's, we've got 2 b's. So what's going to happen? Well, we're going to take out an a and an a. Whatever we circle, we can take out. That means we're really taking out a squared. We can take out ab. We're left with this square root. The only thing we didn't circle is this a. And we are done. Let's take a look at the squaring. Squaring always means multiply that term to itself. And we're dealing with radical x minus 2 times itself. We're going to multiply a radical x times a radical x. A radical x times a radical x is just an x. Remember that? We talked about it in Chapter 7. You've got two of the same items, just like we saw up above in that previous problem. That means just one x can come on out. So I have minus 2 radical x as I distribute. Here we'd get another minus 2 radical x. Finally, negative 2 times negative 2 is a plus 4. So negative 2 root x and a negative 2 root x is negative 4 radical x plus 4. And we are done. Number 15, my form is a little bit different than the one that you were given in class. I had to clean mine up a little bit. Look at the handwritten form right here. Obviously, what you'd like to do is turn this into one radical so that we can divide. And we'll have 8a to the 4th b to the 8th over 2a to the 3rd b to the 5th. And then we just simplify. 8 over 2 just becomes a 4. We can subtract using that property that we talked about before. 4 minus 3 is a 1. 8 minus 5 gets you 3. And as we do some factorization with 4 divided by 2 is 2. So we know we have a 2 times 2. Here's a single a. And we have 3 b's all in a row. We're looking for two of the same thing. And you can see that we have circled a 2 and a pair of b's. So we can pull out a 2b. What are we left with? Well, inside we just have an a and a b. Let's take a look at number 16 together. Number 16, we can subtract a 3 from both sides. Get that radical alone. We've got radical x plus 5 is equal to 3. When you want to get rid of a square root, however, you can square both sides. You'd be left with x plus 5 equals 9. Subtract a 5 and you'll get x equals 4. Honestly, though, we should do a check. Honestly, the best thing to do is to store a 4 in for an x. And let's just see if this left-hand side is going to get us what we're really looking for. We've got radical x plus 5 plus a 3. Hit enter and you'll get 6. It checks. The reason why we have to do a check is very frequently our answer won't work. In the original equation, we'd have to say no solution. Number 17. As you're looking at number 17, you can see that the degree is asked for. The degree is simply the highest power that you see in the expression. The degree, plain and simple, is 5. Take a look here at number 18. Number 18, we can add a 2 to both sides. We'd have radical x would equal 7. Now what? Well, square both sides. 7 squared would get you 49. Now again, be careful. You want to make sure that this really is going to work. I'm going to take 49, press store right here by the 1 button. And I'm just going to type in the square root of x, hit the right arrow to leave the radical, hit -2. That's your left side. If it works, we should get a 5. It does. It works. It checks. And we're good to go. Okay, obviously on a multiple choice kind of a test, you're not going to have a graphing problem per se, where you have to create your own graph, but you can definitely be asked about the domain and the range of a radical function. And just to help you out, use your calculator all the same. We can go to y equals, type in a 2, and type square root of x plus 3, hit the right arrow, say plus 5, and you can definitely get a graph going here. Hopefully you remember x files. You think about something with -3. We might be shifted 3 steps to the left. Indeed, we will be. The plus 5 will be a vertical shift upwards 5. So if you were to hit zoom standard, you can see that square root shape. It's going to be 3 steps to the left of the origin and 5 steps up. But the table can really help you out tremendously. You can see that it's at -3 for our x values where we begin. It's our starting x value. What's our starting y value? You can see it's a 5. This is the beginning of the graph. Right here you might remember we could say x is greater than or equal to -3, y is greater than or equal to 5. The picture would show that just as well. You can be to the right of -3 for x. Your y values must be equal to 5 or bigger. Well, we're going to use our calculator now for number 20. And for number 20, we're going to type in these numbers and then just use the calculator to help us out. We're going to put that in for our list. So we'll hit Stat, Edit, and here's our L1. We can hit 2, Enter, 11, Enter, 4. You just keep typing these all in, and it's really nice that you can see what you're typing in here. Looks like we were almost done. This is maybe the longest part of the problem. 23, type in a 5. And now what? Well, go to your home screen, press Stat, go to the right to go to Calculate. We're going to press 1 for one variable statistics. Just hit Enter 3 times. And sigma, which is our standard deviation, would be about 6.722. So the calculator does all the work for us. And again, this is a measurement of how spread out our data is. For 21, we're asked to find the difference, a subtraction, if you would, of f and g. So what do we have for f? Well, we have 2x plus 1. I'll say minus. Well, here's 5x minus 2x squared. And I'm going to distribute that subtraction, distribute that negative. This becomes a minus 5x and a plus 2x squared. Let's combine our like terms. There's only one squared term. We have a 2x and a minus 5x. That adds up to a negative 3x. Then we have a plus 1. And then we're done. All right, as we look at number 22, and we'll end our video here. For 22, radical 12. Let's do a division tree for 12. 2 goes in, leaving us with a 6. 2 goes in again, leaving us with a 3. So this is really 2 times 2 times 3. Let's do a little division tree for 18. 2 goes into 18 9 times. 2 does not go into 9, so try a 3. 9 is divisible by 3, you get 3. So this 18 is really 2 times 3 times 3. Well, join these two radicals together. I've got 1, 2, 3 2's, and I have 1, 2, 3 3's. You can count them off. We're really looking for groups of 2 items. So out comes a 2, out comes a 3. I didn't circle a 2 and I didn't circle a 3 over here. Final answer will be 6, radical 6.